Okay, the QRS complex. QRS now is the depolarization of the ventricles. They are contracting, or we call that it's depolarizing. It happens very quickly, but there's a lot of electrical activity there, so it's very high. Notice it's very peaked way up here, so that shows more movement on the electrocardiogram. It should be less than 0.12 seconds, or basically less than 3 small boxes from the beginning of that QRS right here to the end of the QRS. So here's your Q, your R, and your S at inch right there. So that should be less than 0.12. This is the ventricles. They are repolarizing. So that's the second sound you hear on a lub dub of electrocardiogram. Let's feel your pulse. Here's your lub and here's your dub. The T wave. Now the T wave, remember, is getting ready for another depolarization of the ventricles. So there's enough activity there electrically that it shows a little bump, kind of like your P wave. So that comes right after a QRS. So that's basically repolarizing the ventricles, getting ready for another one. So it's a resting phase of the heart cycle. You know, we now had a lub, we had a dub, we rest, we're going to start right in for the next one. That's your T wave. So interpretation of an EKG strip. We want to look at the heart rate. How fast is it beating? Want to know if the rhythm is regular or irregular. Do we have a P wave? If it is normal sinus rhythm, meaning that the electrical beat, heartbeat, is starting in the sinus node, there should be a P wave before every QRS. We should have a PR interval within the right time. Then we should have a QRS. So normal sinus rhythm should have a P wave. There should be that PRI interval. There should be a QRS, and there should be a T wave. And those should be present on every heartbeat on the electrocardiogram if it is a normal sinus rhythm. Now it can be fast, tachycardic, or slow, bradycardic, and if it has all those components there, it's still a sinus rhythm. We just call that Sinus Brady or sinus tachycardia. So on a 6-second strip, there's more than one way basically to count up how fast the heart is beating. So one way is you count the R waves in a 6-second strip, times it by 10. That's one way to do it. We don't have the time to look at an EKG and start from 1 and count all the way up to 120. So there's lines on the EKG strip that basically says this is 6 seconds. How many QRSs do we have in 6 seconds? So you could count the R waves, you could count the QRSs between each 6 seconds, times it by 10. That's one way to do it. There's other ways, but this is probably the easiest, so this is the one that I'm telling you about. So here's your 6-second mark on your EKGs. It's a great big bright red one, bolded between what's going on. So here we have 3 seconds, here's 6 seconds. Notice this is 1 second, so 6 seconds, 1 second, 3 seconds. These are the ones we usually look for, are the 6-second marks. Notice, if we look at this, we go, okay, well, it looks like Eldon just explained it, but I have no idea what we're talking about. Well, we just basically start from the very beginning. We look at each one of these and say, do I have a P wave in front of a QRS with a T? Yes, I do. Let's look at the next one. I have a P wave, QRS, and a T. P wave, QRS, and a T. Notice I have a P, QRS, and T for each one. That tells me it's going through the normal electrical pathway of the SA node, the AV node, and down through the ventricles. So this is a sinus rhythm. Now between these QRSs, I could add them up and go 1, 2, 3, 4, 5, 6, 7, 8, times it by 10, 6 seconds divided into a minute, 10 times. I've got 80 beats per minute. This would be normal sinus rhythm, 80 beats per minute. Now, you can't really see it as well, but basically if you time these out, each one of these QRSs should happen the exact same time between each one, meaning it's regular. This is a regular sinus rhythm. So what's the rate here? Let's pretend this is a 6-second strip. 6 seconds, how many QRSs? Times it by 10. This is 100 beats a minute. So 100 beats per minute for this 6-second strip. If we analyze this one, notice once again, we have a P wave and a QRS and a T. P wave, QRS, T. P wave, QRS, T. We have one of those in every one of them. So we have normal sinus rhythm at 100 beats per minute. It looks like it's pretty regular. Each one is regular right across. They look like it's even. So it looks like a regular rhythm. So heart rhythms are classified as either regular or irregular. And another way to do it, which you don't need to worry about, is sometimes we call them regularly irregular. So there's a pattern that's irregular, but it's in a usual pattern. So it's regularly irregular. But we're going to just look at regular and irregular. So is there an established pattern between the QRS complex? Does it look like it's the same? We measure that R to R. We can measure the P to P. So that's what we look at for the heart rhythm. The reason the R to R and the P to P is important is that's how we decide and we can figure out if there's a heart block or something going on with the heart that's not normal. So notice the P wave. Let's start from the beginning. Let's look at this. Do I have a P wave in front of each QRS? Yes, I do. Are they occurring regularly? Well, I've got one in each one. Yes. I have a P wave in front of each one. This looks like it's pretty much the same time between this QRS and this one and this one. I would say it's regular. Do all the P waves look similar? Yeah, you can tell these are all P waves. They look pretty similar. Now, we can do the same. Do all the QRSs look the same? Yes, they do. Do all the T waves look the same? Well, pretty much. Notice this one's a little bit thinner than this one, but we still have a T wave. Okay, the PR interval. Now, I said before that we have to look at those little boxes to figure out how much time is elapsing. A PR interval should be normally anywhere from 0.12 to 0.20. So if you were able to use a computer, you could actually measure out how long it took between that PR, the P to start, and the QRS to begin. Normal PR interval shouldn't be more than 0.12 or 0.20. Is it lesser or greater? If it's lesser than this, it's okay. If it's 0.11, that's all right. If it's between these two, that's okay. If it's over 0.20, then something's going on with the electrical impulse leaving the SA node and getting down through the AV node. So that's how we decide if there's something wrong with the SA node or the AV node. Look at that interval. Okay, a QR complex. Are the complexes greater than 0.12? Meaning are they wide, or are they less than 0.12, meaning they're narrow? If it's a normal sinus rhythm, those QRSs should be within that 0.12 or less. That tells us that the electrical impulse is traveling the route it's supposed to. So on this one, notice they're all nice and narrow. If we time this out with each box, that would be less than 0.12. So they're nice and narrow. Notice on this we have a P wave, T, P, QRST, P, QRST. So we have to look at that. Now a wide one right here, and if it was larger than 0.12, we might have something going on with the electrical pathway and there's a block causing it to be wider and something's abnormal with the heart. Now, if you look at a 12 lead EKG, there are lots of different ways a QRS can look. We're just using one lead read to learn how to do that. But you can have different QRSs on a 12 lead that instead of going up or down or up, they're going to be down. So this one you see a Q and an S. Notice we don't have that Q here and we don't have that S here. So basically this is just referred to as an R wave. It's really a ventricle, but we just call it an R. Here's an RS wave. Here's a QS wave. Here we have a QR, but we don't have that S coming down. Here's a normal QRS. Here's a QS and another R before it comes down. These are all forms of ventricle depolarization. These are all ventricle contractions. So this one doesn't mean something's wrong with the heart. It's just the lead that the heart that we're using to read. So it's the way that 12 lead is looking at the heart. So if you're seeing those, don't panic. Don't panic. So types of rhythm. I mentioned before, we have bradycardia. It's when a heart rate is less than 60 beats per minute. Normal is a rate of 60 to 100. Tachycardia is when it's over 100 beats per minute. So that's a simple way to describe a heartbeat. It's Brady, it's normal, it's tachyc. So where is it coming from? Well, I mentioned that if it starts at the beginning, a sinus rhythm starts at the SA node, you should have a P wave. So here's something called a junctional rhythm. Notice we have a QRS and a T, QRST, 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 but we don't have a P wave, which tells me something's wrong with my SA node. So I've got QRST with no P wave. This is not a normal sinus rhythm. Something's blocking that sinus rhythm to send out an impulse. So remember I said the Purkinje fiber and the bundle of His, they can initiate electrical impulses. They have initiated an electrical impulse someplace, probably right before the AV node, right at the AV node, and it's working. You still got a heartbeat here, so it's called a junctional rhythm, but there's no P wave. So ventricle rhythm. Remember, what are the rates of the ventricles if they are going to initiate a beat on their own? Remember what that was? 22, what was it? Okay, look back in your notes and remember. Now, I also said that if it's, you can have narrow or wide QRSs. Here's an example of a very wide QRS. Notice it's not together, it's wide. It's got this great big, here's your R, and it goes way down here. These are wide QRSs. Those are not normal. Although the heart can do that, because if there's a blockage and I have initiated an electrical impulse in my ventricle somewhere, this is what it would look like. It's wide. It tells me it's a ventricle initiated impulse. The ventricles are contracting. Notice it's much slower. If this was a 6-second strip, this is barely 40 beats a minute. So that's an example of a wide QRS, not a narrow. Wides are not normal. Something's going on with the heart. So sinus rhythm, just to review, we have normal sinus rhythm. It could be sinus Brady or sinus tachycardia. So here's a sinus Brady rhythm. If it's sinus, it should start from the SA node and work through, and it should be normal, meaning we have a P in front of a QRS with a T. So here we have P, QRS, T. We have all the components of a normal sinus rhythm, P, QRS, T, P, QRS, T. So normal sinus rhythm, but it's Brady, so it's sinus Brady. We have all the components. So if this was a 6-second strip, it would be 30 beats a minute. Very slow.